everyone, welcome to the channel. Python is scripting, general purpose, high level and interpreted programming language which also provides the object-oriented programming approach. In this video, we are going to learn about Python operators. Operators are nothing but the special symbols which are used to perform operations on the variables in Python. For example, if I give 2 plus 3, then plus is the operator here and 2 and 3 are the operands. So I press enter, I get the result as result of adding 2 and 3 as 5. So before learning in detail about Python operators, we need to know about two terminologies. One is called as operator precedence. And the other one is called as associativity. Operator precedence is nothing but the set of rules governing the order in which expressions involving multiple operators and operands are evaluated. The calculation order of expressions is determined by the operator precedence. So in Python, parenthesis has high precedence. It is followed by exponentiation operator. It is followed by star, slash and percentage operator. That is, it is followed by multiplication, division and modulus operator, followed by addition and subtraction operators. And when we have multiple operators of the same precedence in an expression, associativity is the order in which an expression is going to be evaluated. Almost all the operators have left to right associativity, and the exponentiation operator has right to left associativity. The next is, there are 7 different types of operators in Python. Let's see each one of them in detail. The first one is called as the arithmetic operators. So in arithmetic operators, there are different types of arithmetic operators. One is plus, the other one is minus, that is addition operator, subtraction operator, multiplication operator, slash operator, and slash slash is used for division in Python. And then you have the modulus operator represented by the percentage symbol. And then you have the exponentiation operator represented by the star star symbol. So there are 7 different types of arithmetic operators in Python, namely plus, minus, star, slash, double slash, star star and percentage. Plus is used for addition. Minus is used for subtraction. Star is used for multiplication. As far as division is concerned, there are 2 types of operators for division in Python. One is the slash and the other one is the double slash. The slash slash operator performs truncating division, which means it returns an integer result and ignores the remainder if any. For example, if I give 8 slash slash 2, it gives me 4. So if I do the same with slash operator, it gives me 4.0. So in Python version 3, when both the operands are integers, the slash operator performs true division. That is, it returns a floating point result. In case if either operand is a complex number, it is going to return a complex result. You also have the built-in Div Mod function. So if I give Div Mod of 4, 2, it's going to return me a pair whose items are nothing but the quotient and the remainder. So you don't have to use both slash slash and percentage for the quotient and the remainder. The next is exponentiation operator. Exponentiation operator is represented by star star in Python. So exponentiation is nothing but the raised to power operation. Exponentiation has right to left associativity in Python. That is, the order of evaluation of expression will be from right side to left side and not from left to right. Say, for example, if I give two star star 2, I'm going to get the result as 65,536. That is, here what happens is the expression is evaluated from right to left because exponentiation operator has right to left associativity. Always remember that. So from the right side, 2 to the power 2 is 4. 2 square is 4, and then 4 to the power 2 would be 4 square is 16, and then 16 to the power 2, that is 16 square would be 65,536. You also have the power of method. If I give power of 2, 2, it performs the same thing, computes the power of a number. So power of method computes the power of a number by raising the first argument to the second argument. The next is percentage operator. Percentage is called as a modulus arithmetic operator. When applied to integers, percentage is the modulus operator and it returns the remainder of division operation. But if the first operand is a string, then percentage is used as the format operator in Python. Say for example, if I give 4 modulus 2, then I get the remainder of the division of 4 divided by 2 is 0. So I get it as the result. Next, we'll see about the different types of assignment operators, comparison operators, and logical operators in Python. The different assignment operators are, first is basically the equal to operator. This is used to assign a value to a variable in an expression. That is, it assigns the right-hand side operands to the left-hand side variable. Then you have the plus equal to, minus equal to, star equal to, slash equal to, slash slash equal to, star star equal to, and percentage equal to, which is called as shorthand assignment operators, which is nothing but if I say a plus equal to 5, it means a is equal to a plus 5. If I say a star equals 5, it means a is equal to a into 5. So it is an example for shorthand assignment. Also remember that equal to is the assignment operator and equal to is the comparison operator. The next is the different types of comparison operators. The different comparison operators are used to compare the different values of variables. So they are less than, to compare if one value is less than the other value, we use the less than symbol, then the greater than, then the equal to compare if one value is equal to the other value, we use two equal to symbols. Not equal to is represented by this exclamation mark followed by equal to. Less than or equal to is represented by less than and equal to symbols. Greater than or equal to is represented by greater than and equal to symbols. Then we also have the logical operators. There are 3 logical operators: and, or, and not in Python. Now let's see about it with an example. Suppose if I say a is equal to 2 and then I use the shorthand assignment operator a star equals 5 and then I print the value of a. When I do that, I get the value of a as 10. That is a star equal to 5. This will do a is equal to a into 5. That is 2 multiplied with 5 gives me the value as 10. The value of 10 will be stored in the variable a. And so the value of a is printed as 10. Similarly, if I give a slash equal to 5 and then I say print of a, I get the result as 2.0. So here I have used the slash operator, which always performs true division and returns a floating point result. The next is, so same way for all other assignment operators also. The next is about the comparison operators. Comparison operators are used to compare two values and print out the result. And we also have the logical operators, which are used to perform logical operations on the given relational expressions. There are 3 logical operators, namely and, or, and not. And comparison, membership, and identity operators have higher precedence than the logical operators in Python. And associativity of logical or and this logical and operator is left to right. Okay, the logical not operator is non-associative. And the order of precedence of logical operators in Python is the not has higher precedence compared with and, logical and the logical and has higher precedence compared with logical or. That is the order of precedence. That is the order in which the operators are going to be evaluated if they are all present in an expression. So let's test it out with an example. If I say a is equal to 1, b is equal to 2, c is equal to 3, and then I check whether a equal to 1. I'm using comparison operators here as well as logical operators, or b equal to 2 and checking whether a is equal to 1 or b is equal to 2 and c is not equal to 3. So it gives me the result as true. As I told, the order of precedence is not has higher precedence than logical and. Logical and has higher precedence than logical or. So first this expression b equals to and c not equal to 3 will be evaluated. Here B equals 2 is true. C not equal to 3 is false. So true ANDed with false will give me false. Okay. If even if one of the input is false, the result will be false in the case of logical AND operator. So this result will be false. And then I have A equals 1. This is true. True odd with false will be true. In the case of logical OR operator, only if both the outputs are false, it is going to give a false. Otherwise, even if one of the input is true, it's going to give a true. So true odd with false, true with OR operator and false will give me true. The next is same way if I give not of A, let's say I add the logical not operator and then I say not of A not equal to 1 or B equals 2 and C not equals 3. Just now we saw B equals 2 is true, C not equal to 3. So here the order of precedence is not has higher precedence compared with logical AND. So first not operator will get evaluated. So first one is A not equal to 1. A is equal to 1. So A not equal to 1 will be false. Not of false will be true. So I execute this, not of false will be true. And then the next precedence will be, order of precedence will be for the AND operator. B equals 2. So this is true. C not equals to 3. This is false. So this expression will evaluate to false. B equals 2 and C not equal to 3 will be false. This first one was true. Already we evaluated. True applying the OR operator with false will give me true. Even if one of the input is true, the output will be true in the case of logical OR operator. So the result is a true. Next, we'll see about identity and membership operators in Python. There are two identity operators. One is and the other one is not. Similarly, there are two types of membership operators. One is in and the other one is not in. So this is and is not identity operators are used to test two objects to see if they both refer to the same object in memory. Say for example, if I give x is equal to, I create a list with one element and then I say y is equal to 1 and then I give x is y. Okay, this is false because x is a list which contains one element, namely 1, and y is a variable which stores the value 1. So both don't refer to the same object in memory and so the result is false. So even if x equals y is true, x equal to y is true during comparison, x is not y may also be true. So same way if I use x is not y, it gives me true because x is not y. So that is about identity. And the next one is membership operators. Membership operators are in and not in. So if I say x in yes, it means the x in yes operator tests to check whether object x equals any item in the sequence yes. Okay, that sequence yes can be any kind of iterable sequence or any other kind of container. And it returns, this in operator will return true when that particular object x which you are comparing equals any item in the sequence. And it returns false when it is not equal to any of the item in the sequence. The x not in yes operator is equivalent to not of x in yes. And for dictionaries, x in yes tests for the presence of x as a key. In the specific case of strings, x in yes will test whether x equals any substring of yes, not just any single character. It will not check for any single character, but it will check whether one particular substring is present in the set of string or not. Say for example, I create a list and I store 3 names in it. Okay, I have created a list and I have stored 3 set of strings in it. Then I do print I check whether the name Swati is present in the names list using the in membership operator. So here, just note that I have used one string here and I'm checking whether this string is part of the set of strings which is present in the names list. So it is false because the string Swati is not present in the names list. Similarly, I check whether I use the not in operator and check whether the string Shashi is not in names. It gives me false because the string Shashi is present in the names list. These are the different types of bitwise operators. First one is the bitwise AND operator represented with the ampersand symbol. Second is the bitwise OR operator represented by the pipe symbol. Third is the bitwise negation operator represented by the tilde symbol. Fourth is the bitwise exclusive OR operator represented by the tilde symbol. And then you have the bitwise left shift operator represented by less than, and bitwise right shift operator represented by the greater than symbols in Python. So these bitwise operators have higher precedence compared with comparison, identity, and logical operators. So let's see each one of them. First is the bitwise OR operator. So in bitwise OR operator, if at least one input is a 1, the result is a 1. So before that, remember that it is going to operate on the binary bits of the input. So whatever integer is given as input, that will be converted to its binary form, and operations, these bitwise operations will be carried out on the binary bits of the input, and then the result will be converted back to the integer form or the decimal form. So in bitwise AND operator, result is a 0 if one of the input is 0 or both the inputs are 0. And in bitwise negation operator, it inverts or changes each 1 to 0. If it is a 1, it will be converted to 0, and if it is a 0, it will be inverted to 1. Say, for example, negation of 7 would be minus 8. Basically, it performs minus of x plus 1, where x is your input number. So minus of x is 7 here, minus of 7 plus 1 would be 8. So the result would be minus 8. So if you see in binary form, 7 in binary would be 0, 111. And if you invert each of its bits during the bitwise negation operation, 0 would become 1 and all the 3 ones would become 0. So 1,000 is actually 8 in decimal. So it'd be getting minus 8 as the result. Similarly, negation of minus 8 would be minus of x plus 1. That is minus of minus 8 plus 1 would be minus of minus 7, which in turn will give you 7. And the next one is XOR operator. XOR stands for exclusive OR. Exclusive OR will produce a 0 as output if both the inputs are same. That is, if both the inputs are 0 or both the inputs are 1, it's going to produce a 0. Else, it is going to produce a 1 as output. So, for example, if I give 7 and 8, 7 in binary form is 0, 1, 1, 1. 8 in binary form is 1, 0, 0, 0. So 7, when I apply the bitwise OR operator on the 7 and 8, if I say 7 bitwise or 8, I'd be getting, so in the case of OR operation, 1 odd with 0 would give you 1, and 0 odd with 1 also would give you 1. So all of the result is 1, 1, 1, 1. 1, 1, 1, 1, when it is converted to the decimal form, you'd be getting 15. 15 would be the answer. The next 7, when you do bitwise AND operation on 7 and 8, what will happen is, even if one of the inputs is a 0, result is going to be a 0. 1 ANDed with 0 would be 0. 1 ANDed with 0 would be 0. And then 0 ANDed with 1 would be 0. So finally, you'll be getting 4 zeros, which in turn converted to decimal would be 0 as output. Similarly, 7 exclusive OR of 8. So if both the inputs are same, if both the inputs are 0, 0 or both the inputs are 1, 1, it's going to produce a 0 as output. But here both the inputs are same doesn't happen. Either it is 1, 0 or 0, 1. So the result would be 1, 1, 1, 1, which in turn would be 15 in decimal. Then when you apply the negation operation on 7, as I told before, the result would be 1, 0, 0, 0, because 7 would be 0, 1, 1, 1. So when you apply the negation operator, all the bits would be inverted. 0 would be converted to 1, 1 would be converted to 0, and we'd be getting minus 8 as the output. The last bitwise operator is left shift and right shift. X left shifted by Y bits. It means shift the binary representation of x up by y bits. That is, the bits of x would be shifted left by y number of bits. So in integers, the result would be x into 2 power y. When you do left shift operation, result would be x into 2 power y. When you do right shift operation, it is represented by greater than symbols. X right shifted by y means shift the binary representation of x down by y bits, which means the bits of x would be shifted right by y bits. This is equivalent to x divided by 2 power y. Okay. So for example, here you have 6 left shifted by 1 bits. The binary representation of 6 is 0, 1, 1, 0. When you left shift it by 1 bit, each of the bits would be shifted left. 0 would go to this position, 1 would come to this position, 1 would come to this position. So you'd be getting 1, 1, 0, 0. 1, 1, 0, 0 in decimal would be 12. Similarly, when you do 6 right shifted by 1 bit, you would be getting binary representation of 6 is 0, 1, 1, 0. When you right shift by 1, you would be getting 0, 0, 1, 1. And in decimal, it would be 3. When you do another example would be 2 left shifted by 4. So 2 in binary would be 0, 0, 1, 0. When you left shift it by 4 bits, you'd be getting, so you'd be getting 0, 0, 1, 0, 0, 0, 0, 0. So this would be 32 in decimal. When you do right shift of 2 by 4, you'd be getting the binary bit of 2 is 0, 0, 1, 0, right shift by 4 bits. So when you do right shifting by 4 bits, 0, 0, 1, 0 would become 0, 0, 0, 0. And so the result is 0. I give 7 bitwise OR of 8. I get the result as 15. I give 7 bitwise AND of 8. I get the result as 0. I'd give 7 exclusive OR of 8. I get the result as 15. I give negation 7. I get the result as minus 8. I give 6 left shifted by 1. I get the output as 12. I give 6 right shifted by 1. I get the output as 3. I give 2 left shifted by 4. I get the output as 32. 2 right shifted by 4 gives the output as 0. So that is all about the different types of operators in Python.